So say I want you to use Cramer's rule to solve the system of linear equations in three variables. So we get 3x minus y plus z is equal to 5, x plus 2y minus 2z is equal to negative 3, and then the last equation is 2x plus 3y plus z is equal to 4. Now recall, the solutions for Cramer's rule are given by x is dx over d, y is dy over d, and then z is dz over d. Right? That's right. So, first thing we should do is find all of these determinants. So let's start with d. So d is found to be the 3 by 3 determinant that's made up of the coefficients of x, y, and z. So the first column is going to be the coefficients of x, so 3, 1, 2. The second column is going to be the coefficients of y, and the last column is going to be the coefficients of z. So now we can solve this determinant, and I'm going to use the expansion of minors method or the cofactor method. So the first thing we should do is pick a row or a column to expand upon. I guess I will pick the first column. Usually I like picking columns that either have a lot of zeros or don't have any negative numbers. Since we're going to be alternating signs, it kind of helps us keep things on track. So let's do that. So we'll do 3, 1, and 2. And for the expansion of minors method, what you want to do is multiply each of these terms by its respective minor. So recall how to find the minor of 3, for example, is you get rid of the row and the column that it belongs to, and you write the numbers left over as a 2 by 2 determinant. So 2, 3, negative 2, and 1. So get rid of all this green here. So for the second term, the 2 by 2 determinant is going to be negative 1, 3, 1, and 1. And finally, the last term, the determinant is going to be negative 1, 2, 1, and negative 2. And then finally what we do is we use the sign array. Let me write the sign array up here. How you come up with the sign array is that it's a 3 by 3 determinant, but instead of numbers you start with a plus sign on the top left corner, and then you alternate across the row, and then down the column, and then you continue alternating, so that no two pluses and no two minuses are right next to each other, right? So this is the sign array. And since we're going down the first column of the sign array, our signs are plus, minus, plus. So we want to be plus, minus, plus. So there you go. Not so bad. So now let's simplify. This becomes 3 times the determinant of this, which you cross multiply and then take the difference. So 2 times 1 is 2, minus 3 times negative 2 is negative 6. Then minus 1 times negative 1 minus 3 times 1 is 3. And finally 2 times 2 minus 2 times 1 is 2. So simplifying further, we end up getting 3 times 2 minus negative 6 is 2 plus 6, which is 8. Then minus 1 times negative 1 minus 3. That's negative 4. And then finally 2 times 2 minus 2, which is 0. And anything multiplied by 0 is 0, so this term cancels out. So simplifying, again, 3 times 8 is 24. And then minus 1 times negative 4 is the same thing as positive 4. So for D, we end up getting 28. And I'm gonna box 28 just so that I can keep track of what I'm doing here. So now we found D, we have to find dx. Now dx is a 3 by 3 determinant, except in this time, because it's dx, we replace the x coefficients with the constant terms. So the first column is going to be 5, negative 3, and 4, and then the y column is going to be negative 1, 2, 3, and the last column is going to be 1, negative 2, 1. So negative 1, 2, 3, and then 1, negative 2, 1. So now we expand again, and expand using minors. And this time I'm going to pick the last row because it's got no negative numbers in it. So I'm going to write each element along with its minor. So 4, its minor is going to be negative 1, 2, 1, negative 2. And then 3, 5, negative 3, 1, negative 2. And then finally 1 times its minor, which is 5, negative 3, negative 1, 2. Okay, so, and now we go back to the sign array at the very top, and since we're choosing the last row, it's also going to be plus, minus, plus. So we're just going to put a minus and a plus over here. So now, let's do this. So 4 times this determinant, which is 2 minus 2, minus 3 times negative 10 minus negative 3, plus 1 times 10 minus 3. Okay, simplifying it, 2 minus 2 is 0, so this term cancels out. So we're left with minus 3 times negative 10 minus negative 3, which is negative 10 plus 3, which will give us negative 7. And then plus 1 times 10 minus 3, which is 7. So simplifying, this becomes 21 plus 7, which is 28. So we get 28 for both d and dx. So now 2 more to go, dy. And dy is a 3 by 3 determinant, except this time we replace the y coefficients with the constant terms. So our determinant's going to look like 3, 1, 2, then 5, negative 3, 4 as the second column, and then the last column is the coefficient of the z's, so 1, negative 2, and 1. So now expanding again, it looks like expanding by the first column might be the best bet. So I'll write each element along with its minor, so 3, and its minor is going to be negative 3, 4, negative 2, 1. Minus 1. Remember, down the first column, the signs are plus, minus, plus, so since we already know that, we can just write it down. So 1 times its minor, so we have 5, 4, 1, 1, and then finally plus 2 times its minor, which is 5 minus 3, 1, negative 2. So let's simplify. This becomes 3 times negative 3 minus negative 8, minus 1 times 5 minus 4, and then 2 times negative 10 minus negative 3. So this becomes, in the next line, negative 3 plus 8, that's positive 5, minus 1 times 5 minus 4, which is just 1, and then plus 2 times negative 10 plus 3, which is negative 7. So we have 15 minus 1 minus 14, which is 15 minus 15, so we get 0. So our dy is 0, which is okay, because we can have a 0 in the numerator, but if d were 0, then we'd have a different problem. So finally, dz is the 3 by 3, and let's going back up here, what we do is we replace the z's now, the z coefficients, with the constant terms. So our first column is going to be the x coefficients, which were 3, 1, 2. Our second column is going to be the y coefficients, which is negative 1, 2, 3. And then our last column is going to be the constant terms, 5, negative 3, and 4. So now let's expand again. Looks like the first column is going to do it for us one more time. So we have 3 times its minor, 2, 3, negative 3, 4, minus 1 times its minor, excuse me, 1, 3, 4, and then 2 and its minor. So simplifying, this becomes 3 times 8 minus negative 9, minus 1 times negative 4 minus 15. Oops. There's an extra parentheses I didn't quite need. And then finally 2 times 3 minus 10. So simplifying is 3 times 8 plus 9, which is 17, minus 1 times negative 4 minus 15, which is negative 19, and then finally 2 times 3 minus 10, which is negative 7. So 3 times 17 is 51, plus 19, because it's minus 1 times negative 19, and then minus 14. And combining these all together, you're going to get 56. So now we found our dx, our dy, and our dz, and we're in a position to solve. So x is dx over d. So let's recall what these were since it was a while ago. D was 28 and dx was 28. So we got 28 over 28, which simplifies to 1. Y is dy over d, and dy was 0. So 0 over 28 is just 0 since it's in the numerator. And then finally z is dz over d, which is 56 over 28, which I believe simplifies to 2. Yes, it does simplify to 2. So, since we write our solution in terms of the ordered pair x comma y comma z, we say that the solution is 1, 0, 2.